Welcome back, fellow arcade and electronics enthusiasts. Today, on a wonderful Sunday, I am starting to look at a Star Wars board set. Just got it out of the box, just took it apart, set that stuff over there, and looking at the interconnect PCB. It's always the first thing I do is check these things out. And this one you will see is damaged. See that? That pin right there is no bueno. That is not fixable, so that has to be replaced. And I do have those, so I will replace this. And this board set was reported as just having goofy graphics. That could be the whole problem. So first thing let's do is let's replace that, and then we will put this thing on the bench. You know what? Let's do first. Let's put this together as is. No, I don't want to do that. Just trust me, it's the note with it is it has weird graphics. The enemy fighters don't look right. And it's got issues. So my guess is that could be the whole entire problem, because that connector is the video board connector. You know, you have video board, CPU board, sound board. So we'll go ahead, replace that guy, put this set up on the bench, and try it out. Alright, you know what? I changed my mind. Let's do it. Let's go ahead and do it before. Before I change it, let's put it together, put it up on the bench, and see what it looks like. Okay, I got the Star Wars harness out, and I've got the board. I got like a piece of foam between these boards, and I don't care about the soundboard right now. So we just have our two, our video and our CPU board plugged in, and I've got it hooked up to the vector monitor. So we'll go ahead and fire it up. I do have to plug in the AR supply. All right. Yep, okay, here we go. It's running. The lights flashed. So far so good, but remember what was reported was the enemy fighters and gameplay graphics are totally goofed up, is what was reported. Which I might have to... Boy, that's really... I mean, when you have that, I never have it spread out to cover the games. I don't have a Star Wars game. I always have it kind of small. I mean, so far so good, but I need to coin it up and check out gameplay. So by all means, let's do it. And where is my coin stuff? Okay. Oh, I gotta spin it around. I gotta turn it off, turn it over so I can access the, touch the coin stuff and that kind of. No, the coin stuff's right here. Let me get a, this will do, ground. Coin is 2 credits. How do you start this thing? There we go. We'll just let it count down. Just let it count down and see what happens. TIE fighters incoming. Yeah, see that? TIE fighters are goofy, not right. Yeah, see that stuff's doing this. Looks shaky and jittery. Big time pin cushion over there and over here. Yeah, just goofy graphics. Alright, going to turn it off. And I'm going to replace that connector. And we'll revisit. Okay, I actually went ahead and just put my, my test connector on there. And it's still doing the same thing. So the plot thickens. It's not just that, even though that does need to be replaced because it is a looming problem. So that does need to be replaced, and I will replace that. But we have other issues. So we will have to think about what's going on here. I would say this has to be an analog issue. This could be, we could have bad voltage regulators up here. For sure we could. It could be bad power. I have seen funkiness like that because of bad power. So that could be an issue. Yeah, I don't know. That would be a test. It's probably nothing with test. Let's reset. Check out our test. We don't have to listen to that annoying boop, 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 boop nonsense. Okay, no errors detected. That is some serious pin cushioning. Okay. No errors. In aux coin. 10D, 10F. Pot test. Okay. No dividor errors. There's no errors. That's good. It's just kind of movie, jumping around. That screams voltage regulators to me. This is good. All right. We do not have a CPU board problem. It's on this board, and my first thought are voltage regulators. 100%. These things are fire friggin' hot. Yeah. All right. Maintenance. I'm replacing that because that has to be replaced because that will be a problem in the future. Guaranteed 100%. And then I'm doing some maintenance up here. I'm replacing the power regulators. And then we'll see where we're at. Okay, lucky. It's my very last one. I'll have to buy some more. And you got that one removed nicely. And we'll put the new one in. Here's the old one, by the way. The old one with that bad pin. Couple bad pins. I didn't notice that. Did that get... It might have got like that when I was removing it. I don't know. And here's the two regulators. I've replaced those guys. So we'll go ahead and put this on there and we'll be ready to test. Alright, and there is the nice new connector on there. Wonderful. Yeah. Alright, so let's hook this thing back up. I'm going to do it side by side to begin with, because I know this is good now, and I know this wasn't causing the flaky graphics. So that'll be fine. But I'm going to lay it out side by side and fire them up. See if the regulators were the issue. These guys. Okay, we are hooked back up. New regulators. And I'm looking at it, and let me restart a game. It's like some things have improved, definitely, but some things are still not right. One credit. Is that start? Yeah, start. So there are still issues. In a lot of ways, I think it's a lot better. But in some ways, it's still not right. See, it's still... The TIE fighters are still not correct. This could be an AVG chip problem. Yeah, see, it's still goofy. It's either AVG. AVG is my next guess. This guy. And if it's not that, then I'm going to move on to the two DACs. And there's two DACs. I would suspect maybe there's another DAC, I believe, over here. I don't even know what that DAC does. I would like to look at the schematic and find that out. I don't think it's an op amp. If it's not this thing being funky, I would say it's one of the DACs, or probably one of the reference DACs, the DAC 08s. But this one handles the linear zooming, this guy right here. So I don't think it's that one. I want to know, what does this do? Yeah. What does that DAC do right there? I don't know. So, yeah. I'm going to look at the schematic a little bit. But first, I got one of these, so I'm going to just pop it in there and see if that takes care of it. Because I see these little dots up here, and it seems like these dots, it seems like I remember those being a byproduct of bad AVG. Maybe. But that's an easy check, so I'm just going to pop a new one in there and see if that clears that up. If not, then I'm moving on to analog section. I do not think this is anything digital other than AVG. That thing can cause weirdness. If it's not that, I'd say it's got to be something analog. So let me go ahead and pop a new one of those in there, and we'll see what that does. If anything, it might fix it. Who knows? All right. I thought I had one of these, but I didn't. So I had to put together one of my TTL AVG boards. And I had to do this. I had one of these little surface mount chips. I ran out of 193, so I had to doctor that up into a perf board. Yeah. Anyway, it's still doing the same thing. Yeah. Same weirdness. So I am going to move on to DAC chips, I believe, and make sure those reference DACs are good. Yeah, the stars even look really. This looks really just weird. The stars and stuff. It's just not right. So we will figure it out. Okay, I've done a couple of things here. Number one, I've messed around up in the analog section. I actually replaced all of the op amps, all 5 amps. And as soon as I did that, I realized this is not an op amp issue. This is a digital problem, and it's on this board. It has to do with the math function, even though we're getting no math errors. There's something not right there. So I think one of the clues are these little dots in the corners. And these stars just act all strange and jittery. Yeah. I did remove and try new 384 multiplier chips just to eliminate that. That was not the issue. The issue is on this board somewhere, I believe. I don't think it's this board. But yeah, so good fun. We'll have to figure it out. And I guess I'm just going to consult the schematic and start looking at all of this math stuff that's on this board, because it only happens with the stars and the stuff flying around and stuff like that, which is all, originated and generated on this board. All that mathematics and stuff like that is done here. So I'm going to regroup and go at it from a different angle. All right, well, I believe I have found the problem. What we have here is, I was just looking at my analyzer, a 374, LS 374, right here. These guys right here. It's the dividend latch, and I am on 4L, which is this one, which is the high 8 bits of this dividend latch. It's okay, 374, and I had to get the old data sheet out to actually. My question was, okay, here, I'll show you what this looks like. The top line is output enable, the second line is clock, and then you have the input and the output. My question was to myself, when output enable goes low, does whatever on the data lines get transferred to the output? And the answer is not necessarily. The answer is whatever has been latched into this thing is what's getting spit out. Really what I need to do is I need to see what is being latched into this and then what is being output. See, it might have 4 latched into it at all times. I highly doubt that. It's always 4. I'm going to do a little bit more analyzing on this, because the way this thing works, the flip-flops internally on a 374 can continue to latch and store data. It's only when output enable goes low that that stored data gets dumped onto the bus. So what I really need to do is set up this trigger, and I might have to do the, I don't know, I'm gonna look into it, because I want to trigger on the clock and see what actually gets clocked into internally on the flip-flop, and then look at output and see what is being dumped out. My guess is, I mean, this is always 4. You mean this thing doesn't do anything in the output enable? I don't think this is working. 4 is always being latched into this thing. You know what I can do is I'll trigger, let's do this right now. Let's change the trigger and trigger on clock. So let's go stop, go to the trigger, and done. You know what we need to do is I need to clear the trigger, and let's just look at the clock and see if it's always 4 next time we get a clock. This thing only clocks during two screens, basically. When this turns to the high score table, right there, yeah, see, it clocked 4. And we'll wait again. If it clocks 4 again, then this is actually working properly. Yeah, see, it clocked 4. And then when it's output enable, it's enabling 4. So this thing, actually, I thought I was onto it, but I'm not. This is actually working properly. I'm going to monitor it a little bit more. Yeah, that's how a 374 works. The functionality of it will continue to work regardless of output control. It's just whenever output control goes low, whatever is stored internally in that latch will get dumped. Now I do need to check, I'm only checking 4 bits at a time. I do need to look at the other 4 bits on the other side of the chip. So I'll do that, and yeah, I'll be back. This is not, so far this is not the issue. Okie dokie. Well, I found something that was really weird. This is prior work, and it is these 2 chips, 1 chip. Alright, it's 191 right here in the block index counter. Pin 7. Pin 7 goes from, it's an output of the 191 here. And it goes, it's block index count 7. In block index count 7, the only place that it goes to is right here. Pin 6 of the 157, which is this guy. So pin 7 over here goes to pin 6 over here, and that's the only place it goes to. Now, I had both of these chips removed, and there's clearly a signal on pin 7 going from 7 to 6 over here with no chips in the board. So there's definitely some funny business going on with this work. So I'm removing all the prior work. I'm removing this socket, and there was another prior work socket right here. I'm removing all 3 of those sockets, cleaning up, and I'm going to reinspect and reinstall these sockets. That is the only... I did these two, so I know those are good. But this one, there's something weird going on there. So I'm removing those and finding out why there's a signal where there shouldn't be. It should just be floating, no signal there. But there's clearly a clear signal, clear sound wave signal, digital signal on that line, which is really strange. So, yep, I'm going to go ahead and take care of that. Something is shorted to something on there. So I'm going to clear that up. You know what I should do is I should show you. Let me show you. I'm going to hook this back up. I'll turn the scope back on and I'll show you the signal that is on there. And keep in mind, block index count 7 is right here. The only place that it goes to is right here. Pin 6 of the chip next to it. This one goes to this one. So let me hook this up really quick. I'll hook it back up, turn it back on, and I'll show you that signal that is clearly on that pin. Okay, we are hooked back up and running. So if see, we're running. Now I will, remember that was pin 7 of this guy. See that? Now if I slow the roll on this thing, and look at that, let's slow it down even more. There. That is what is on that pin. Pin 7, which is an output of this 191, goes to pin 6, and that is the only connection. It's one wire from here to here. So how in the world is this digital signal on that signal? Right, here's what they should look like. Here's the other outputs. There's one, just kind of nothing. Here's another one, floating. Here's another, nothing. That's what those should look like, not this. You shouldn't have a signal on it like that. So I gotta think that that's causing an issue somehow. Something's shorted to something, because that shouldn't have a signal on it like that. So, alright, I'm going to go ahead and take it back apart. I'm going to remove these sockets, clean up, and just double check everything. Alright, I kind of went through and cleaned up this area because there was a lot of corrosion right in here. So I took sandpaper, fine grit. What is this, 120? 400? I don't know. It's 400. And just kind of sand it down a little bit, down to copper. And then I retinned it. And yeah, good as new. Got rid of the corrosion. So I'll put a new 0.1 cap in there. And we're good to go. I did remove this 385. It's an adder subtractor. And this, I just want to take it out of the board and test it because I don't quite understand how these things work. They have internal flip-flops that aren't really described how it works, to be honest. On the data sheet, I looked at the data sheet and I just didn't get it. Something about it's two inputs and an A and a B input, and subtract is A minus B, addition is A plus B, but there's internal flip-flops before the clock and after the clock, and I just didn't get it. So I was like, you know what, I'll just remove it and put it in a tester. So, yep, Yeah, there's a few chips on here that analyzing. This one's a two's complement multiplier or something like that, and you know what? I'll just try another one. I'll just remove them, which is what I did. I removed them, put new ones in. It wasn't the problem. That's how I eliminate these. So, yeah. It's much quicker to do that than it is to try to understand and analyze the things. Just put some new ones in there and see if it works. And if not, okay, good. Put the old ones back in. That's what I'm doing with this 385. I'm going to socket this, put a new one in, and if I get the same results, I'll put the old one back in. It's that simple. So, but, all right. Well, I'm going to get to it. I'm going to put a socket in here and have that ready to go. Put a couple sockets in here, and I'll be back. Okay, I have it back on, and you can see we have basically no stars. There's a twinkle of a star here and there. But I don't have that 385 in the board, or I didn't even put sockets in the board here yet. But the good news is, if I now probe pin 7, remember 7 had that signal on it. Now there's no signal on it. And remember that went over to pin 6 of this guy. And there's no signal there. So I don't know what that was all about. Because I didn't see a short with my meter. It didn't beep out a short or anything. But there was clearly a signal on there with the scope. And I cleaned it up. I got the new cap in there, you can see. And I cleaned it up, and now there's no signal on pin 7, which there shouldn't have been in the first place. So now I want to just repopulate, put the sockets in, put the chips in, and hopefully that fixes it. Because that clearly had a signal shorted to it. So, I don't know. We'll see. Be back. Alright, got a couple sockets in now. New sockets. And pin 7 has no signal. Just like it should not have a signal. So let's go ahead and populate the 2 chips in there. And I already did test these 2 chips in my reader, my tester, and the chips are good. So we're just going to put the chips back in the board and see what happens. Okay, chips in the board. And let's take a look. How do our stars look? Let's turn this off. Our stars should not jump and jumble all around. They should just be smooth and come out at you on the blue screen, the blue high score screen. After this fades out, then we'll be at the high score screen, and our stars should just come out at us, not be disappearing and jumping all over the place like they have been. I don't know. It still looks the same to me. I'll have to do gameplay. I'll be back. Alright, just a touch of an update on the Star Wars board set. I started analyzing the 299s, and there's 5 of them on this board. And I just decided it is easier to just remove those and put them in a tester to see if they're good or not. is the amount of time it takes to sit and analyze what's going on with one of these. It's just much quicker to remove them and pop them in a tester and test them. So I went ahead and did that. And they're kind of difficult. They're kind of difficult to test because they store. They're a storage register, basically, too. So you have to go back and see what's clocked into them and then look at the clock pulses after that and find out what's shifting and what's going on. It's more difficult than like a 194, where 194 doesn't really store, it just shifts. So I'm getting ready right now. I'm off this board for now because I can't find anything bad on this board. Now, we did have that one weird signal on this guy, remember, which makes no sense. That makes no difference. That's just one of those head scratches, like, what was that all about? There was clearly a signal on that pin, and when I cleaned it up, that signal was gone. So I really don't know. That is a head scratcher. But yeah, who knows. But I'm moving on to this board right now, and I'm going to start with the data shifting. Because how this works, there's data that comes over, a bunch of control lines, address lines, and data. I'm just going to start following the data lines. They come through and they go through a 245, probably this guy right here. And that it allows this board to write to and receive from this board. And those signals become these DVG signals. So I'm just going to follow the data and make sure that it's being shifted properly and stuff. This is a head scratcher, this problem is. It really is. Because everything works good except for the stuff that is produced in the math and matrix stuff, which just screams this board to me. But I can't find anything wrong with this board. So I'm figuring maybe the data that's coming from this board is not being handled properly. And plus, we put this in test and we get no errors at all. With matrix errors, no math errors, math box, matrix, nothing. We get no errors on this board, which this is a new one for me. Because normally if this board has an issue, it'll show in the test. But this board, see, what's throwing me is all of the character type stuff. And you'll see this in like a Tempest or something like that, where the character screens are perfect. The high score table and everything. But everything that is gameplay related, say the sprites, if you will, in a vector game, that's all calculated. All that stuff is calculated in the math part of the board. And the math box in Star Wars is on the CPU board. But to think about it again, though, the AVG chip did take the place of the auxiliary board, say, on a Tempest. So this, in a sense, kind of is a math box in itself, maybe. So yeah, long story short, this has been a difficult find because I've been stuck on this board because I've been convinced that this board was the issue. And I don't know if I did this on video, but I dumped all of the software. I got my reader out. I checked these instruction prompts. They're fine. I find no issues with this board. So I'm going to trust the self-test and move on to this board. And I'm going to start with, like I said, these 194s here, shifting the data. We'll start looking at those. Okay, I found something a little bit interesting. I am analyzing right now this decoder because I wanted to look at these signals right here because they enable the block index count. And I was just curious about that. I was checking that out. So I started analyzing this guy, and I've noticed something that is even more interesting. Anyway, this thing, if I do a single shot, it will sit here until our two screens that are in question pop up. Now, it's not going to happen here. Okay. After this screen fades out and it goes to the high score screen, this will enable 6 and 7. And then when that screen fades out and it does the Star Wars screen, it'll enable again 6 and 7. Kind of get in on both. You'll see this do a I missed it because I didn't have it on single shot. Anyway, it's on single shot now. You'll see that you see this thing flashing. It's waiting for a trigger. I am triggering on. See, it just did it. When it switched over, it triggered. So bottom line, this thing is only enabling twice. At the beginning of the high score screen and at the beginning of this screen, it enables 6 and 7. 6 and 7 are DVD DH, DVD DL. That's 6 and 7. Those two signals are right here. These two latches, dividend latch. DVD L, DVD DH. It clocks these two guys. Is that all it does? Is it anywhere else? I'll have to scour the schematic for these two signals, but I think it's probably just these. And what it's doing is it's clocking these two latches, these 374s, at 4L and 5L, which are 4L and 5L, which I've got marked good. So I don't know how I looked at those. I don't think I analyzed those with the analyzer. I'm going to reanalyze these two latches, make sure. I don't remember looking at those. So I'm going to redo that. And then I'm just going to follow this DD, these DD signals. You know, they go into this these shift registers, the 299s, which I've already checked. Those are good. Gosh, this is a pain. Finding this problem is a total pain. But yeah, I'm going to look at these two latches really closely. Make sure that they are actually dumping the right data here. And the data that they're getting is dB, which comes from this business. So I suppose it'd be good to make sure this data coming in is good, because, you know, garbage in, garbage out. So this shift registers right here, the quotient is being fed into this and then being dumped onto whatever bus this goes onto. It comes over here to the dividend shift register. Yeah, so this page, I need to concentrate on this page right here, because I'm still convinced that this is a CPU board problem, even though I'm getting no errors. You know, because everything's good except for two screens and the gameplay screen with the moving stuff. So yeah, I'm not buying it. I don't think it's the vector board. So I'm going to scrutinize this page next. I know I have not looked at these 164s, and I don't remember doing these. I know these are good, so that's a good thing. I do not know. I think Okay, this guy I know is good. The 191. I analyzed all the 191s. 109, I'm not sure. I'm sure it's probably good. But yeah, I don't know. We'll find out. All right, getting back to Star Wars. I took a break from Star Wars to finish up the track and field repair. And I'm looking at some 164s. And I found one that is not correct in one specific bit. And this is a weird problem. This is a hard one to find. I went ahead and eliminated the DACs as an issue. Even though I knew it wasn't them, I didn't know. No. These are current devices. You know, they produce a current that goes to deflect the beam. So that's really hard to tell if they're good or not. The only real good way to see if they're good is to just replace them with new ones. I did. I got the same thing, though I put the old ones back in. And I'm back to the CPU board because I know I'm 98% sure this is a CPU board issue. And I have found something that is definitely not right on this board. This 164 here is just chugging along good. You can see right here. Let's start right with this pulse. This rising edge of the clock. We have a 1 being pumped in. A determines, right? B basically determines. So we got zeros being pumped in. We have ones being pumped in right here. So right here we get this. So with the next one, this is a 1 being, we'll have 1 0 and then all ones at this pulse, and we do 1 0 and all ones. Now this is going to be followed by a bunch of zeros coming in. 1 2 3 4 zeros. So at the end of this we should have 4 zeros and ones, which we do right here. So let's just move ahead to our next one. This is actually still a 0 right here. See this? This is actually still a 0. So we'll have 4 ones and 4 zeros, and we do right there, 4 ones, 4 zeros. And then we have a 1 come in, so we have 3 1s, zeros, and a 1. This is going to be another 1, which it is right here. And then we have a 0 come in, so we're going to have 1 zeros and 3 1s. Or that's not right. We're going to have 1 zeros and then 1 0, 1 1 0, and we do. Getting confused myself. Now we have another 1 come in here, so we're going to have 4 zeros, 1 1 0 1, which we do. And then we have another 1, so we're going to have 3 zeros, 1 1 0 1 1, and we do. Okay, we're chugging along. Now we got 2 zeros come in, so we're going to end up being 0 1 1 0 1 1 0 0, but we're not. Yeah, we are. 0 1 1 0 1 1 0 0. Okay, we're chugging along good. We have a 1 come in. We do right here. That's good. Now we have a 0 come in, and we do. And 2 more 1s, so it'll be 1 1 right here. Okay, now we're looking at 1 2 3 zeros. So on this one we have 3 zeros. 3 zeros, what? 0 1 0 1 1 0 1 0 1 1 and 3 zeros, and we do. That's good. Now we have 2 1s come in, so we have 0 1 1, some zeros and 2 1s, which we do. Okay, so where was this not right? No, never mind. This thing seems to be working just fine. Goodness gracious. Okay, well, I gave in and I contacted my friend who has a Star Wars, thanks John for hooking me up, to do some board swapping. Find out which board do I need to concentrate on, because I'm going to tell you right now. Let's look at the CPU board. This is the CPU board from the customer that I'm working on. Let's look at all of the green dots and replacements. This has been replaced. Green dots. There's one. There's green dots. The green dots means I've analyzed them and they are fine. Those two have been, I replaced the 244s just because I was pulling my hair out and clueless, not clueless, but frustrated. Green dots means analyzed and verified. Rams are good. Green dots. I verified the ROMs are good. Now, I'm going to swap these ones from this other board into these, because maybe these break down when they have heat on them or something. I don't know. Green dots. That obviously looks like a... oh yeah, I remember I removed all of the 299s and just put them in a tester. These are all analyzed chips. And none of those. Couple there. I believe I've analyzed the 161 there. But I've gone through so much of this board and I was getting so frustrated. And I know the problem is on this board. It just makes sense. Even though I don't get an error in test for MathBox and stuff. Well, my suspicions are correct, because this is customer's board, vector board, generator board. And this is my friend John's Star Wars CPU board. And when we get back to our, let me go ahead and just reset it. And you see the stars come out and you can follow the stars. They like come out at you. Yeah, they're not all herky-jerky. That's what it's supposed to be like. Yeah. And if we go ahead and start a game, let it do its countdown, and then you can see how it just looks correct. And another thing is when it shows the Death Star and you're going down into the trench, the Death Star says, "May the Force be with you," but it's jumbled on the other board. It doesn't print out "May the Force be with you." But you can see these things look perfect. That's how they're supposed to look. That's what it's supposed to look like. There is some circuit that is just not right on that CPU board, and I just haven't been able to find it. Yeah, when this zooms in, you'll see it. It'll say, "May the Force be with you." Or did it? Maybe you actually have to have some points or something for it to say that. Yeah. But the problem is the CPU board. So, as I thought it was, and I had actually gone through and analyzed the data shifters, the 194, there's 6 of them. you know, the XY data shifters. I analyzed those. I analyzed some 175s. There's a 191 or so on here. I actually analyzed quite a bit on this board, and I was like, I just don't think this board was the issue. And it's not. It's this board. It's that board. So we'll put this one back on it and just continue on. Alright, I actually got under the microscope and was searching for shorts. And I actually noticed, and you don't really need a microscope to notice this, but I don't know why I didn't notice it before, but these 3 capacitors that were on this board all leaked. And this one up here. So this little bit of an area, I've gone ahead and stripped out that area. There's a handful of parts, not much. There's no parts over here, just the caps. I'm going to clean this all up, clean that up, re-tin it, and you know, there's a handful of resistors. There's 4 resistors and some, you know, 0.1 caps. No big deal. So let me go ahead and clean that up, put it back together, and I didn't find any shorts, so that's good. I did find some flakage, you know, around, and I scrubbed some flaky, you know, some flaky junk, tin flakage off of the board, but I didn't see any shorts, so we have to have a logic failure somewhere. All right, I'll be back. All right, got that nice and cleaned up, re-tinned, repopulated. I put 220 microfarad caps in. I don't have any 100s. These are all new. That guy's new. Same LED. And I resoldered those guys in. Nice and cleaned up. Got rid of all that corrosion. And up here, I had to replace this portion of that trace. It just got way ate up. It was bad. And a couple caps. All the corrosion is removed, which is good. So now we can continue on after getting that cleaned up nicely. Yeah. Very good. Alright, back to it. Alright, I am looking at a 245. There's 3 of them right here. The other 2 look absolutely fine. This one is just kind of flaky right here. Where right here the direction says it's pulling from B to A, and B's 1 the whole way. And then 1 should be, or A should be 1 this whole time that this is enabled. And it's got this nonsense over here. It's got zeros. I don't like this 245. So, yeah. Yeah, this thing, this whole time this is enabled, this is the enable pulse, this is the direction, and when it's low, it's actually pulling, it's allowing the B side of the bus to go to the A side, and over here on the A side, we have zeros. This should be 1 the whole time, and it's not. So something is not right there. You know, it's either the 245 or it's something on this bus, maybe could be corrupting it or something. Something's not right here. So I think what I'll do is I'll pull this 245 and check it in the reader, because I don't like that at all. That's not right. So the others look absolutely fine, but that one's just, you know, in the bottom 4 bits of this one look fine. I'm doing 4 bits at a time. I'm doing the top 4 bits right now, bits 0 through 3. And yeah, that's not good right there. It's not. So we'll see. And if we look, 4H is right here, that 245, and it says matrix processor data selector. Well, that is the kind of problem that we're seeing with the graphics and stuff. So could that be our issue? Well, that's definitely not proper right there. So could it be our issue? We'll see. Okay, I have replaced that 345. It is right here, the one I pulled out of the board. And I put a new one in there, and it did not fix the problem. So I wanted to analyze this again, because clearly we witnessed this thing did not work properly. So I'm back on those, you know, first 4 bits 0 through 3 on that chip, and it looks to be way cleared up now. At least here it's basically writing from A to B. I look at this as, if it's high, it's writing. It's probably not what it's actually doing, but it makes sense to me, my brain, for that. See, it's writing A to B. So 7 is going down, 7 and 8 going down during the pulse. See that? Here, C0, 0, 5, 0, 8, 4. And right here, it's reading from B to A. And remember, when it was reading from B to A before, 1 was all jumbled. You see now right here, there's no jumbling. It's actually just not right. Why is this staying 0 all this time? This is not correct. This should be 1 all the way over here. So something is not right with this. When it's pulling from B bus to A bus, something is not right. See, sending down to A to B is fine. Here it's pulling a 0 up. As long as it's 0, it's fine. Writing 1, 3. Right here again. This should be 1. See, it's pulling B up to A. So this should be 1 the whole time it's enabled, and it's not. So something's got to be with that. So it's actually not the chip that was bad. Something else is bad. So I'm going to get the schematic out and look at that and see what is going on. What is that business right there? So let's take a look. Well, guys, I have met my match with this one. I'm calling it quits on this Star Wars set. It's displaying the exact same thing it was when I got it. I did verify that this board has the issue. With my friend John, he gave me a set to kind of swap boards around, and I've narrowed it down to it is the CPU board that has the issue. I have, look at the work I've done to this thing. I've analyzed about everything on here, and then when I got to a point where I had nothing really left to analyze, I started just removing chips out of the board, thinking that maybe there's a short underneath the chip or something like that. So I just started removing chips, and I then test the chips in either that or my tester in the house, verify that they're good. I'd actually put new chips in the board, test it, get the same results, put the old chips back in the board. And I mean, I've removed so much of this board and socketed it. I actually am running out of sockets. I did run out of 20-pin sockets. These are new chips that I soldered into the board right here. But I have analyzed about everything on here, and I can't find a single bad circuit. I can't find anything that even looks remotely close to being bad. Everything's tested good. I even went through under the microscope, and I've been over this board with a fine-tooth comb. I've analyzed under the scope the front of it, the back of it, looking for shorts, looking for breaks, looking for anything. Can't find a single thing wrong with this board. There just comes a point in time where I have to move on. Unfortunately, you know. So I don't know. I don't get it. Anyone have any ideas on this one? I would love to hear it. But I think there's something up with the board itself. You know, I don't know. There's something going on. There's a short somewhere that I can't see, that I haven't found, or something. Something's not right on this thing. Because I don't see any floating lines at all. There's nothing like a broken trace that I've found. And I've been on everything on here. I have been on literally every chip on this board. So yeah, sometimes, I mean, this is the first time, I believe this is the first time I have ever thrown in the towel on a board. Yeah. But, I mean, you got to do what you got to do. This one beat me. But it's the same exact, and I've beeped all of this out. I've looked at all of these signals coming onto this, and, yeah, this is a great big question mark. So, who knows? Who knows? Anyway, very anticlimactic, very depressing. I'm actually very sad about this. You know, I don't like not fixing stuff, but there just comes a point in time where I have to let it go and just move on to the next. So, all right, well, anyone have any ideas? Post down in the comments. I might hold on to this one for a little bit longer and maybe get some new perspective, new thoughts, or whatever on something. Now keep in mind, with my friend John's set, I can put his CPU board on this customer's vector board, and it's fine. It's this board. Something with this board. And also, just keep in mind, I have been through this thing with a fine-tooth comb. I have looked at every single trace under the scope on this thing, and there's no breaks. There's nothing like that. It's a great big mystery. Yeah, but very, very unfortunate. Anyway, any ideas? Let me know in the comments. Sorry for the no repair, but yeah. We will see you on the next, hopefully successful, Classic Arcade repair. Bye for now, guys.